This is 11.6 lesson, cross-sections and prisms and cylinders. So today we're going to learn how to find the lateral area, surface area, and volume of prisms and cylinders. First of all, with the cross-section, it is the intersection of a 3D object. So 3D object and a plane, as shown. So here you have a triangular pyramid and you have a plane that crosses through it, and it creates a triangle as the cross section. So the triangle part is the cross section. We can find the area and perimeter of these cross sections. And here we're going to say what kind of shape was formed. So here you have a cube, it's being cut through just the middle. So what's formed here would be a square. But if you were to cut it along the diagonal is longer than the side length. So therefore, we have created a rectangle. If you cut it this way, we form a trapezoid because these two lengths, you've got those two lengths. Not sure if those are the same, but it looks like this length is going to be longer than that length. So trapezoid. Here, if you cut it in the corner, you make a triangle. Here for a cone, if you slice the cone, you get a circle. So we're assuming that this is parallel to the base here. And here you can assume that this plane is cut parallel to the base as well. So that would create a hexagon. And the next section, it says polyhedron is a solid that is bound by polygons that enclose a single region of space. It's just a three-dimensional object that is formed by polygons. A prism is a polyhedron with two congruent faces called bases. So a prism has two bases, where a pyramid only has one base and the sides kind of touch at the point. That's a pyramid. Your base is parallel. Your bases are parallel, and then you have lateral faces. So these are the lateral faces as shown, and then lateral edges, and then you have two bases. And then we can find the surface area. The difference between right and oblique, for right, it says, for right, that's what you can normally think of with a prism. So the edge is perpendicular to both bases. And an oblique prism is a prism with lateral edges that are not perpendicular to the bases. You also have, this would be different, the height here, this would be the slant height, is different from the altitude height. And you can also find the volume. So first of all, we're going to talk about the surface area first. So to find the surface area of any prism, no matter what the base is, you're going to take the lateral area and add two of the bases. So lateral area plus two of the bases. How do you find the lateral area? Well, if I were to take this figure here, this triangular prism, and open it up like a net, so just the lateral edges, you have three lateral edges that are all rectangles. So if I were to open it up like that, you'd have 1, 2, 3. Each of these represents a side length. So side, 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 and if I were to add all those up, I would get the length. Now if I were to add all those up here, that would be the perimeter of the base. So to find the length, the entire length of the lateral edges, I just find the perimeter of the base. So lateral area is perimeter of the base times the height is still just going to be the height. So times height. So here, lateral area, we can be more specific with that and say perimeter of the base times the height plus 2 capital B, where capital B stands for area of the base. And then volume of a prism, we just take the area of the base and multiply it by the height. Probably familiar with that formula. For a cylinder, same idea, except you're working with circles. So you're going to have circumference instead of perimeter, and area of the base is always going to be pi r squared. So your lateral area is going to be perimeter times height, but like I said, perimeter in this case is called circumference, and the circumference is, the formula for that is 2 pi r, so 2 pi rh. But I would just think of it as this still, and then just know circumference times height, and then you can do the 2 pi rh. And then surface area is the same, so you would do perimeter times height plus 2 bases, or you can think of it as circumference times height plus 2b. And then you can plug in your more specific formulas related to pi. For volume, same thing as the other one for a prism. Area of the base times the height, where area of the base in this example for a cylinder is going to be pi r squared. So pi r squared h. And let's do 3 examples. So for this one, this is a triangular prism laying on its side. So this is the triangle that's going to be the base. So there's one base, and there's the other, and then 12 is the height of the prism. So we're going to find lateral area just within surface area. We don't need to find it separately. Surface area equals lateral area plus 2 bases. Lateral area is perimeter times height. If I wanted to know the perimeter, I would have to do 5 plus 8 plus whatever this side length is, because there's 3 sides, so I don't know that. But since this is the right triangle, I can use Pythagorean Theorem to get it. So 5 squared, oops, that is a 5, it looks like an 8. 5 squared plus 8 squared equals h squared, or yeah, h is fine, you can use x. Now, here's a rule for edge elastic, is that if you're rounding to the nearest tenth, let's round our intermediate calculations to 2 decimal places. You could always, and on a test or a quiz, you could just leave your answers as exact answers, but for edge elastic, so that we can all be on the same page with the rounding, because even if you're off by a decimal place, it's going to mark it wrong. Let's do this rule. So 5 squared plus 8 squared equals h squared. If you solve for that, hang on a second. I'm just going to try to get through this quickly. So I'm going to use my cheat sheet here. You get 9 square root of 89. 9.43. So then you would add that to 5 and 8, so 13, and get 22.43 for the perimeter. So 22.43 times height. Oh, the height is 12, so that's just 12. Plus 2 area of the base, which is 1/2. Area of a triangle is 1/2 base times height, so 1/2 8 times 5, because 5 is the height of the triangle. Right, if you plug all that into your calculator, you get 309.2 feet squared. For volume is area of the base times height. Area of the base is what we put up here in these parentheses, 1/2 times 8 times 5, and then times 12, and you get 240 feet cubed. Find the lateral area, surface area, and volume for this one. So I'm actually going to come back to this in a minute, because that one's harder. For this one's easy. We just need to do lateral surface area is lateral area, which is perimeter times height, or circumference times height, plus 2 base areas. The circumference here, we know the radius, we know the height, so that's easy. Circumference is 2 pi times r, which is 5, and then times height, which is 12, plus 2 times the area of the base, which is pi times r squared, which is 5. If you plug that in your calculator, you would get 534.1 inches squared. For volume, we're doing area of the base times height. So pi times r squared is the area of the base, and then times the height, which is 12, and you get 942.5 inches cubed. So back to number 2, what we need to do here for surface area is same thing in the previous examples, perimeter, lateral area, so perimeter times height plus 2 base areas. For the perimeter of the base, we have a hexagon, so we would just do 8 times 6 sides, or 48. And then height is 11. What's a little bit trickier is to find the area of the hexagon. So to find the area of hexagon, they kind of showed us how we can make like a little radius that's length is 8, and that's all the way around. So there would actually, we can keep going with that, and there would be 6 of those little equilateral triangles, because if this is 8 and these two are 8, then we have an equilateral triangle. So we need to find the area. If we find the area of just one of these, we can multiply it by 6, and then that would be the area of the base. So to find the area of this, we would need 1/2 base times height. So the base is 8. What we don't know, though, is the height. The height of the triangle is going to be this altitude height, this perpendicular. And with an equilateral triangle, the altitude is also a perpendicular bisector. So that means that this would be 4, and this is what we're trying to find. And you have a little right triangle here. We can use Pythagorean Theorem to find the height of this triangle. So we would have h squared plus 4 squared, and then equals 8 squared, where 8 is the hypotenuse. H squared plus 16 equals 64. Subtract 16 from both sides. You get h squared equals 48. Take the square root of that and round to 2 decimal places. Like in the other examples, on your intermediate calculations to 2 decimal places. Or you can keep it as an exact answer on a test or a quiz, but for Edulastic, we're going to do 2 decimal places. So you get 6.93 for the height. So that you're going to put here for the height formula for the area. So 6.93. And then, so if I type this all in to my calculator, I would do 6 times 1/2 times 8 is 4 times 6.93. If you wanted to be exact, you could just use your answer button in your calculator. 166.32 is the area of the base. And we're going to use that for volume 2. All right, so then put that back up here. So 2 times 166.32. So I'm going to type all that in now. 48 times 11 plus 2 times 166.32. And I get 860.6 meters squared for my surface area. And then for volume is always going to be easier than surface area. For 1, just because the formula is easier. For 2, you've already done all the work to find the area of the base in the surface area. So we're going to have area of the base times the height, where area of the base was 166.32, and the height is 11 of the prism. So that is 1829.5 meters cubed.